Hi guys, welcome to Miss B's channel. Today we'll be looking at how we convert and how we do calculations in life sciences. Hope you've enjoyed your time away from this channel and welcome back to the channel. Hope you're going to learn a lot from our lesson today and hope you grasp as much content that you felt like you do not understand up to this far. So one could ask, what is it that we convert? What is it that we calculate in life sciences? Those are mainly most of the things we calculate. I think excluded is the actual size. Yeah, actual size, magnification. Yeah, those are the only things that I feel like they're not part of this. And then we're just going to do them on a different slide. So currently, we're just going to calculate the difference, calculate the percentage, calculate percentage increase, percentage decrease. And this too, I feel like it's new content in life science that you've never done in the lower grades. So starting FET, which is grade 10, you're going to be introduced to percentage increase and percentage decrease. And mostly in mathematics, you do the difference, you do percentages, you do average and a rate, calculate the rate of change, whether in time, in speed, and mostly this is done in physical sciences, and which is content not mostly asked in life sciences, but we can sometimes ask, calculate the rate between two intervals, and then you just know that you're gonna do the final value divided by the initial value. And according to my concept here, the final value is the biggest value, and then the initial value, which is the smallest value, then that's the value that you're going to get as you do your calculations. But in this slide, we're just going to focus on the difference, percentage increase and decrease, and we're also going to calculate the average. Okay, most of the time when I do recordings, I sometimes take a break, right, to just let in. Now we're going to start with calculating the difference. Let's take now you're given two values to say calculate the difference between 10 degrees Celsius and 20 degrees Celsius. You've got two values, which is 10 colonies and 75 colonies. So calculating the difference, according to me now, my concept says you're going to say big value minus small value. What is it that we have now as 75 minus 10? Then what is 75 minus 10? It's equals to 65 colonies. And always include the SI unit. You always have to include what? The SI units. This 65 represent the number of what? Colonies in the peridot. Between the difference between the 10 degrees Celsius and 20 degrees Celsius. And one could say, let's maybe try out a different value. Then we check the difference within two values. They could either also say, check the difference between 30 degrees now, 30 degrees and 50 degrees. What do? You focus on the value at 30 degrees Celsius, which is 250 colonies, and at 50, okay, 50 is going to just be 0. Let's just maybe try between 30 and 10, right? Maybe let's try the difference between 10 degrees Celsius and 30 degrees Celsius now. Then now you look at the value at 10 degrees Celsius. And then now the value at 30 degrees Celsius is 250 colonies. And then according to this formula that I've tried to simplify for you, calculating the difference, we're going to have 250 minus 10. Because when we say big minus small value, which between those two intervals, between 10 degrees and 30 degrees, which one has the high number of colonies or the big number of colonies is 30 degrees. So we're going to say 250 minus 10 degrees. And remember, even if we say 10 minus 250, now the value is just going to be negative, but we're going to get the same value. But now, according to my formula, to just avoid confusions, we just say big number minus small number. So now 250 colonies minus 10 colonies, we're going to have 240 colonies. That's the difference between 10 degrees and 30 degrees is 240 colonies. And then when we come to the difference between 10 and 20 degrees, we have 675 minus 10 colonies. We're going to have what? 65. We have a difference of 65 colonies from the temperature 10 degrees to temperature 20 degrees. So the only difference between the number of colonies from 20 degrees and 10 degrees is 65 degrees. So which means now we have a total of 65 colonies which were added from what? From the 10 degrees Celsius. From 10 degrees we had 10 colonies. And then by 20 degrees we've added how many? 65, such that now from the 10 degrees we've had an addition of 65 colonies, which make what? 75 colonies. So now this is just how you calculate the difference between two values. It does not matter which data they give you, but you just say big value minus small value within the intervals that you're given, and then you get the answer. Let's just take, for example, before I pass here, they just said here it's with maybe here it's time. It's time versus the number of colonies. We no longer measure the degrees. We look at the time now. It's time versus the number of colonies, such that the time now will become the independent variable and the number of colonies depend on time. So the number of colonies becomes what? The dependent variable, because they depend on the time set. So let's take now this is 30 minutes. And then here's 1 hour. And then we've got 1 hour, 30 minutes. And then we've got 2 hours. And then we've got 2 hours, 30 minutes. Okay, now the question says calculate the difference between 30 minutes and 2 hours, 30 minutes. Or they say calculate the difference between 30 minutes and 2 hours. So pause the video, just try it. And then let's just check possible answers. We said now calculate the difference within okay, I'm sorry for that. Let's maybe use difference from than within, right? 2 hours from or between. Okay, let's say between. Okay, let's say from. I guess either way, from 30 minutes to 2 hours. So now we look at our intervals. We go to 2 hours. Okay. Now we check 2 hours. Here's 2 hours. We have how many? 100 colonies. And then from 30 minutes, within 30 minutes, we had 10 colonies. From our formula, we say big minus small. Then, which means from here, we're going to say 100, which is the largest number of colonies, minus by 10. Then the difference between or from 30 minutes to 2 hours is going to be 90 what? Colonies. So it could be time, it could be days, weeks, it could be temperature, it could be any variable here, right? Measured to check how many number of colonies will be there, right? So you just check from the interval, from what value you are given. Let's take 10 degrees to 40 degrees. You check the values, the number of what? Colonies. You do not say 40 minus 10. You say how many colonies were there, because we are checking the difference in terms of the number of what? Of colonies. If they say the difference in terms of temperature, then you're going to be specific to say 40 minus 10, right? And then which is, let's take the difference in temperature from the first test to the third test. So you see now they're going to say maybe from the first trial and the fourth trial. Then you check 1, 2, 3, 4. The fourth trial it's at 2 hours, and in the first trial it's at 30 minutes. So you go back to say, now we have, in terms of temperature, big minus small. Then you're going to say 40 minus 10. This is the difference in terms of what? Of temperature. Then you're going to get 30 degrees Celsius. This is the difference in temperature from the first trial to the third trial, or from 30 minutes to 2 hours, depending on the data you're given. Because I've seen a lot of learners making mistake in grade 10. There was something that they were supposed to write and they made a lot of mistakes. So now let's continue. Now we're calculating percentage. The rule with percentage, I always say, what is the value that they want the percentage of, and what is the total? Sum total. I call it sum total most of the time. And then I say multiply by 100, right? Value given, value questioned. Let me say value questioned, divide by sum total, multiply by 100. And then this is going to give us a value, and then the SI unit, it's in percentages. So now let's check our data. What is it that we have? Let's take the ask you, what is the percentage of the 20 degrees Celsius, the number of colonies at 20 degrees Celsius, or of the 20 degrees Celsius. Now, which means we want the percentage of how many colonies. Now, we want to know if those colonies out of the total, we've got 75 colonies out of the total, what is the portion of this in terms of what? Percentages. Then we're going to say 75 divide by the sum total. So what is the sum total? Let's do it here. Sum total, it's equals to the sum of everything here. Let's just highlight it. Let me use, now this is okay. Now they want the sum total of the rest of the things here. So which means mathematically we're going to say sum total, we're going to say 10 colonies plus 75 colonies plus 250 colonies plus 100 colonies plus the 0 colonies. Then what is it that we have? Pause and do the sum of the number of colonies. Okay, I hope you've done it. Then now when I use my calculator, I get 435. And let me request colonies. Let me request here, when you do any calculation in life science, don't act mathematics smart. So you just punch each and everything on your calculator, get the value. Yeah, because sometimes you'll make silly mistakes because you just want to add this thing using your medulla. So please, your cerebrum, right? You want to use the cerebrum to calculate here. And just use the calculator. So now the sum total is 435. Then we're going to multiply this by what? By 100. Then also, I'll give you some time to check. Okay, now just hope you've done it. On my side, just confirm so that we do not have maybe. So now if you find that your calculator has a lot of numbers, you round them to 2 decimal, right? Then in this case we just have 2, 4. I'll just show you 1, 3, 7, 9 and other numbers. So you just check the first 2 numbers, right? The first 2 numbers. And then in most cases, you can even check the third number, because if this was 5 or greater than 5, we were going to change this to 17.25 percentage, right? So please always check that. So in this instance, we just have 17.24. And this is 1. So the 1 does not have any impact on this. Then we just leave it as it is. Okay, so now just as a test, just calculate now the percentage of 40 degrees Celsius, the number of colonies at 40 degrees Celsius. Okay, now let's continue. I just hope you've tried it. So let's check. According to our formula, we say what is the value questioned? We are questioning 40 degrees Celsius. I guess with 40 degrees Celsius, we have 100 divided by 45 multiplied by, all right? Okay, so as we said, we're going to check the percentage. What is the percentage at 40 degrees Celsius in relation to the number of colonies? However, the question is, you look at the given value like the formula says. But now, I just say, what is the value at question? You do not calculate the temperature, not focusing on the temperature. We are not testing the temperature. We are testing the number of what? Colonies. So we are observing the number of colonies. So each and everything that we calculate here, it's in relation to what we are observing, which means what is it that we are investigating. Remember, we are not investigating temperature, but we are just using the temperature to observe what? The number of colonies. Then in this case, the percentage at 40 degrees Celsius, we're going to say, what is the value there? It's 100. The value in question is 100. The value given is what? 100. Then what is the total now? It's 435. 435 multiplied by 100. And then which on my side gives me 2. It gives me, I'm sorry for that. It gives me 2 comma 9885. So we said you look at what the first three values, right? The first three values, which is this 8 is above this 8 here, this 8 here is above this 8 here. Let me highlight it. This 8 here, it's above 5. So which means we're going to change this value to 9. So we're going to say 22,99. Then you can just say approximately 23%. Approximately 23%. We can even take it to that extent. Say 23, approximately 23%. Yeah. So that's just it. You can do it using any value here. So now let's check. Now we are here on something that is new to you in grade 10. So let's check. Okay guys, I've realized something or noticed something now. Before we proceed, when you calculate percentages, right, the percentage at 10 degrees plus percentage at 20 degrees, the number of colonies at 30 degrees, 40 and 50, the sum here in terms of percentages, when you add the 17,24, the 22,99, you have to have what, 100% in total, right? But in most instances they do not ask you, right, the percentage of everything. So just calculate what you're given, and then that's it, and avoid mistakes, and kindly just round off to 2 decimals, not more than that. And then let's proceed. Now we have two things, which is percentage increase, percentage decrease, what I love most. So now with those two, you say big. With those two, you say big minus small. And then you say big minus small. Then you're going to divide by. So now that's the interesting part. Then you multiply by 100. I'm going to show you something. What is it that you divide by? In terms of percentage increase, you divide by a small number. And why small? Because when you divide by a small number, you'll get a bigger value. So this is just how the simplest way I memorize this, so that you do not get it and mix up things. If you divide by a small number, you'll get a bigger number. So that's percentage increase, which means here you divide by a small number. So now the abbreviation here, we can just say BSS, right? This is what? Increase. Increase is BSS, or you can say B squared, either way. So always use okay, as I was saying, although I do not use this, but if you want to use it, you can just try, maybe come with abbreviations for yourself. If you have one, like you just know we have BSS or we have BS squared, you'll know if here we divide by under increase, just say increase is BSS. Bring your shit together, right? If you just go BSS, so you know that's percentage increase. Then you'll be able to know if this side I divided using a small number, this side it will be a big number. But mostly I just use the concept of, okay, if here we are looking for an increase, we're going to divide by a small number to get a bigger number. Then that's how I just come up with this. Then when it comes to percentage decrease, you just say big minus small, you divide by big. You're going to get a small number. It looks like it's a decrease or it's a decreased value. So these are the two formulas I use run away or stay away from the initial value, final value, initial, final. Just go big minus small, divide by small, big minus small, divide by big. And it's up to you how you do it. If you want to stick to D and say B as B, it's up to you. So then you know, if you say D is B as B, you know that under decrease we go big value minus small value, divide by big value. Then here if you say I B S S, you know that it's increase, you go big value minus small value, divide by small value. It's up to you, but I always advise people when you study life science, make your own abbreviations so that things are more simpler for you. So that's just it. So let's look at something here. Let's take, they say calculate the percentage increase from 10 degrees to 40 degrees. They say from 10 degrees. Let's highlight 10 degrees. Let's say, I'm sorry for that. They say calculate I'm sorry for that, for the background noise. They say calculate from 10 degrees to 40 degrees. You see now I'm highlighting the 10 degrees, I'm highlighting the 40 degrees. Then we are going to check the values, the number of colonies within the chosen interval. You only highlight the specified values, the given values, as the formulas say. You highlight what is questioned. What are the questioned value? They mentioned from the question, let's take 10 degrees and the 40 degrees. Then you just only highlighted the 10 and the 40. Then you check how many colonies there. You check what we are observing. We're observing the number of colonies. So under 40 degrees Celsius or at 40 degrees Celsius, we had 100 what? Colonies. Then under 10 degrees Celsius, we had what? 10 colonies. Then we say big minus small. Then if we are calculating percentage increase, we're going to divide by small. Then we multiply by 100 because those are percentages, right? So what is the big value there? You do not say 40 minus 10 as I said. You do not say 40 minus 10 unless if the question specified that what is the percentage increase of the temperature. So now if they just say that the percentage increase between 10 degrees, 40 degrees, do not focus on the temperature because that's not what we are measuring. We are measuring what or observing what? The number of colonies. Then you're going to say 100 minus 10. 100 minus 10. What is the bigger value? 100. What is the smaller value? 10. And then divide by the small value, which is 10. Multiply by 100. You're going to pause and check what is the value here. And then the value that you get here, you write it in percentages. And please do not be frustrated when you get that the value that you get is above 100. Under percentage increase and decrease, we can have values above 100%. You can get 101, you can get 250, you can get any value above 100. So let me just specify something before we proceed, or as you are calculating the values there. Want to show you something. If you check here, you do not focus on the 50, you do not focus on the 200. You also do not focus on this value. You only focus on the values that they mentioned. And I'm going to maybe use a different example. And then you're going to also see how do we then apply the concept that we have now. And then if I check now here, when we say 10 minus 100 minus 10, we have what? Let's just go with it. Okay, we have 90 divide by 10, multiply by 100. And then here is going to be 9 multiplied by 100, which is 900. So here we have 900%. And mostly they ask you doable questions, but do not be surprised if you get bigger values like this that I have now. So now let's check if they say percentage decrease, and let's just use the same values. Percentage decrease, we said big minus small, right? Divide by big in this instance, because we want a decrease, you'll get a small number. Then we're going to have 100, still 100 minus 10. Now divide by 100, multiply by what? By 100, it's equals to, because sometimes I've seen a lot of memos, they mark the 90, they mark the 10, they mark this, so mostly it's 3 marks, right? So sometimes if you do not simplify this, you end up not having a mark for this. Actually, the memo does not show this, only shows this, but write each and everything. You can just write this on a formula, simplify this, divide by this, multiply by this, and write the answer here. Okay, then let's check here. We have 90 divide by 100, multiply by 100. Then check on your calculator what value. Okay, so which means now here we have 90 divided by 100 multiplied by, which is 90%. We can always confirm the values as long as you have the formula. I guess we're good to go. So I wanted to show you something. Sometimes they do not give you a table, they give you a graph, right? So let's check what is it that we can, or how can we, with the graph that's specific to the type of, or there's that specific question, we're going to read it out and calculate that question together. And before, lastly, maybe I do this question here. This was a grade 12 paper, but calculating percentage increase and decrease is the same throughout from grade 10 to grade 12, even in grade 10. So I want us to try something different. Something different here. So let's check. They say calculate the percentage decrease from 30 degrees. Okay, let's say 30 degrees to 40 degrees, right? We do not have values in the middle, but you just highlight what is given, right? And then we said we are calculating or observing the number of colonies. So you check the values, which are the number of what colonies, or in a better sense for other learners who can maybe easily understand, you do not calculate the independent variable. You look at your what? Your dependent variable. Okay, so now you said the formula is big. I feel like this highlighter, it's less visible. Okay, I said let me just change this, and we said big minus small. Then because now let's take we calculating percentage increase, we're going to divide by a smaller number, multiply by what? By 100. So now between those two values, which is the biggest value? It's 250 minus 100. And because we are calculating, okay, we say 250 minus 100, we divide by this smaller number here. In this case, it's 100 multiplied by 100. Kindly check what is the value, and then you write the answer in percentages. And then let's take, for instance, the same question was asked, but in this 10, they say calculate the percentage decrease. You say big minus small, divide by big, because now we are calculating what? Percentage decrease. Then thus, you're going to say 250 still minus 100. So now what we change is the denominator. And then we're going to divide by 250, which is the bigger value. multiply by 100. The value that you get, it's measured in percentages. Kindly do the values, substitute here. Okay, let me just write the values so that if you get something different, you know that you've made a mistake somewhere. So this, for this instance, we have 150, and in this instances we have what? 60. And if you check, because I said for percentage increase we get a bigger value. If you check here, it's 150, which is more than the 60. This is the percentage increase. This is the percentage increase. Decrease, increase. Okay, so let's try out the question that we had in metric, and I'm just going to, in grade 12, I'm just going to just maybe analyze the question, and then we'll just answer the question as it is. We're not going to make a possible outcome of it. Possible questions that could maybe used under the same question so that we proceed. The question, it says 3.5.4 says calculate the percentage increase in the speed of impulse between, you see it says between 1 micrometer. You're going to highlight that. It says between 1, okay, 1 micrometer and 3 micrometer. Then it tells you axon diameter of the myelated axon. Myelated is the dotted line. So what is it that you do? You take your ruler, because remember this, as I said from here, you only measure the dependent variable. Where is the dependent variable here? It's this side. Dependent variable, it's on your y-axis, whereby your independent variable it's on your x-axis. So now we're going to use a ruler to measure here. Okay, let me use a pointer before so that we are clear with what we're doing. So from the 1, you're going to go up. When it touches here, you go to your y-axis, and if you check here, we have 2. And some can arguably say that from 1, when it touches the dotted line, is not exactly at 2. So in such instances, such questions, they have what we call intervals to say. If a learner said 2 or 2.1, we can take that. So I want us to highlight the 2, and then which means here, okay, sorry, here we can take 2 or 2.1, right? We can take 2 or 2.1. Then let's now go to a different diameter. Let's go to a different diameter at 3 micrometer. Here we have 3 dotted line here. And if you check, it's not exactly at 8. It's not exactly at 8, it's somewhere below. So this is 7.9. Or we can take an exception of 8. So under here we have 8, or you can say 7.9. But if you check, we are going to take 2.1 and 7.9 because those are the exact values. If you just saw that this is an 8, they can credit you, but it does not mean that's the exact value. So now we are going to say between 7.9 and 2.1, which is the bigger value. Here we say big minus small. divide by small, multiply by 100. Then here they said calculate percentage increase. Yes. So we divide by small. So we say 7,9 minus 2,1 divide by the small values 2,1 multiply by 100. Okay, so now we have 276,190. I'll always show this. So you only focus on what? The first three numbers after the comma. 0 is less than 5. So we do not change this here. So this is 276,19%. So it's 3 marks. This question is what? 3 marks. And if you check here on the question paper, we have what? 3 marks. So it's 3 marks. So a lot of learners said 3 minus 1. Oh, Kosiam. A lot of learners said 3 minus 1 divide by 1 multiplied by 100. And then 3 minus this is 2 divided by this, so which means they get 200%, which was clearly wrong. So you look at your what? Your dependent variable. We measure this. So whether they gave you a graph or they gave you a table form, your data in a table form or in the form of a graph, that's what you do. Right? So either way, even if they asked you to calculate now the percentage decrease, you're still going to say big minus small, divide by big this time around, multiply by 100. Then you also use the same values, which is 7,9 minus 2,1. But now for a change, you say divide by 7,9. Then you multiply by what? By 100. Then you write the answer there. And let's just check if it's going to be smaller than what we had initially. I'm giving you a second to do it. And then when you're done doing it, kindly check if your answer is similar to mine. So now in this instance, I get 73.42%. I got other numbers alongside, which is 7,3,4,177, because now we have 4,177. 7 is greater than 5. That's why I changed this to here. You'll see it when you punch it on the calculator. Okay. Then average. Oh, okay. When we calculate the average, what I always say is that sum total. This is my lamest English so that I can understand. And then I say total number. Sum total and the total number. What do I mean here? I'm saying the sum of each and everything which is here, divide by how many items are there. So we can just rewrite this. Divide by number of items. And then by this, what do we mean? How many items are there? 1, 2, 3, 4, 5. So we've got 5 items. Right? Then what is the sum? Sum total. This is what I call it. We've done it before. 10 plus 75 plus 250 plus 100 plus the 0. So you have to now add the sum of everything here, which is 10, 75, which gives you 85, plus 250, which gives you 235, and then also add with 100, it gives you 435 and the 0. So what we have here is 435. This is your sum total. So when you calculate average, please, when you calculate average, just know that is the sum total divided by the total number of items, or the items given. So now let's look at the formula. They say sum of values given, add them up, divide by a total number of values. So sometimes the values could be just vague and you don't understand what to do about it. So I just say divide by total number of items or values. So we know that we've got 5 items. 1, 2, 3, 4, 5 items. Then add with the sum of those items, which is the 10 plus 75 plus 250 plus 100 plus 0. It does not matter how many numbers you have here. You just have to add the sum of everything which is there. And then now calculate how many items are there. If there are 20 items, you go 1, 2, 3, 4, 5, 6. You get 20 items. You're going to divide by 20. So I'm going to just make an analogy in a classroom, how maybe you get your grade averages and so on and on. So let's just finish this. They say calculate the average of number of colonies or the average of number of colonies, either way. Then you're going to say 435 divide by 5. Then you get the answer. 435 divide by 5, you get 87. 87. This is the average. 87 colonies. This is the average. Always include SI units. That's the average. Right? Okay, so I said I'm going to make an analogy. Let's just do it here. Okay, let's take, we have a class of 7 learners. We have a class of 7 learners, and then those learners, the first learner, I'm going to even give them names. Right, we've got Lee, we've got Leo, we've got John, we've got James, Dumi, Sipo, Tabang. Those are our learners in the class. Then those are marks. They wrote a test. They wrote a test out of 50. Yes. Then they wrote a test out of 15. Let me check if I have a plain page. Okay, I do not. They wrote a test out of 15. Then Lee got 25. Leo got 40. John got 45. James got 49. And Umi got 30. Sipo got 20. Tabang got 11. Oh, Tabang is a bad performer. Then we say calculate the average mark. Calculate the average mark. Then you're going to say sum total divide by total items. Right? Sum total items, I guess. Sum items. Let's just say number of items. Right? Number of items total. Either way, because I don't want to complicate it. So let's just say number of items. Then, which means we are going to add sum total. We're going to say 25 plus 40, 25 plus 40 plus 45 plus 49 plus 30 plus 20 plus 11. That's our sum total. Then divide by how many items or how many learners. We have 1, 2, 3, 4, 5, 6, 7. We have 7. And I think let's just say this. When you're done adding the sum of everything, count the values 1, 2, 3, 4, 5, 6, 7. Then you divide by 7. Whatever that you get here as a sum, the number of sums that you have to add. If here we have, if let's take we had an extra number here as a 6, you're going to go 1, 2, 3, 4, 5, 6, 7, 8. Then you're going to divide by an 8. So in this case, we have how many numbers as a numerator? 7. 1, 2, 3, 4, 5, 6, 7. Divide with a 7. Then what we get here? What do we get here? 220. Then we divide by 7. Then we get 31,43. I've already rounded up. So this is the average. So most of learners get around 31, somewhere between that. If you check, we've got the 30 and the 20 and the 11 and the 25, which drags the marks to 30s. Right, that's an average mark. Each and every learner in this class at least managed to get around 30, right? Yeah, so that's just it. So let's maybe do another example. Or besides even doing an example, let's just say, what percentage did Lee get? So we're going to percentages now. What percentage Leo got? We said with percentages, you say value in question or given, divide by the sum, multiply by 100. Then what is the value that Leo got? Is 40. We are going to divide by the sum total, which is here we got 220. Right? Because now, let me know exactly. So you do not dare make that mistake. In terms of percentages, you get the total mark. Right? Leo got 40 out of 50. Then now, if you calculate the percentage, we say 40 divided by 50, multiply by 100. 40 divided by 50 multiplied by 100, which is 80%. So now just try to make calculate the percentage of Lee. Let's check Lee's percentage. Lee got 25 over 50, and 25 is a half, right? So when you say 25 divided by 50 multiplied by 100, when you say 25 divided by 50 multiplied by 100, you get 50%. So that's just it. So you can use a lot of things here. You calculate average, you calculate. So with average, please just add the sum of the dependent variable, then count the numbers of those values. Then their total gives you whatever that we're looking for here. So let's just make another example, because I don't trust you guys. Really don't trust you. So I will say that now we are no longer in the classroom, we are no longer calculating marks, but now we are looking at let's say we have Taba. Let's write Taba. We say those people were kicking a soccer ball and scoring, right? Then this one had scored 3 balls in scores, right? Let me write scores. Those are the scores. Lee got 3 and Leo got 4 goals in. They had 5 chances each. And then Lee scored 3, Leo 4, John 2, James only 1, Tumi 0, nothing was scored. And then Sipo got 1, Tabang got 5. All of them in, which means Tabang is poor when it comes to books, but at least Tabang can play soccer. And here he is a striker, he can score goals. Then we say calculate the average score. You say sum total divide by number of items. So what is the sum total? We say 3 plus 4 plus 2 plus 1 plus 0 plus 1 plus 5. So what are we going to divide by? Let's count our numerator. Oh, I'm sorry for that. Let's calculate our numerator. Okay, we have 1, 2, 3, 4, 5, 6, 7. So we are going to divide by 7. Then what is our sum total? 16 divided by 7. What do we get? 2,9. Oh, I'm sorry for that. 2,9. Already rounded this off. 2,29. That's the average score, which means at least everyone managed to score at least close to 2 goals, right? If you check, 1 is close to 2, 1 is close to 2, and then this is 2. So about 1, 2, 3 people got close to 2, right? So that's how we calculate average score. Just hope this was helpful. If you cannot now go back to calculate how many learners were there or how many players were there, then you just count the values at the numerator. Then I think we're good to go. Last but not least, this mostly questions are asked in investigation type of questions. And in some, always you have to calculate something. Right, so in this case they just needed a graph and then explaining, identifying, giving one unreliable from reliability, and then independent and dependent. So those questions mostly are asked at investigation type of questions. So here we had this, which was done now, and a lot of learners made a lot of mistakes. So this is what you can have. They can give you a graph, you have to calculate. They can give you table, you also have to calculate. Let's see. It's just here mostly you wouldn't be able to see the possible values here, but we were going to try that and map it out according to the chances here. But let's just try. Although 4 under this we don't have a value, let's just try under 1. We said we have 2,1 plus, let's take, we're calculating the average here. At 2 we have 5, and then at 3 we have 7,9, right? Then if you're calculating average, We said average is equals to sum total divided by number of items. That's what we agreed on. So how many items? 1, 2, 3. So you divide by 3. Then check what is the solution there. 2, 1 plus 5 plus 7, gives us 15. Divide by 3. We are having a 5. So it's 5 meters per second. Right? That's the average speed. 5 meters per second. That's the average speed. So that's just it. You see, we use the graph to calculate the average. So yeah, there could be other possible questions that could be asked. And then we already done percentage increase and decrease. We check the values, the intervals that you're given, and you calculate. And I guess this is the end of our session. In the next time, we're going to do the reliability, validity, aim, and hypothesis. And then I guess in that way, we'll be moving in the right direction. And I'm going to make a different recording where we discuss the actual size. I feel like it's simple, but most learners just make silly mistakes. And then until we meet again next time, this is from Miss B's channel. Bye.